Greetings, everyone. So here we have a monster graph. It's not really a monster graph yet, but still it's a big one. And we have to find the shortest path. So it's going to take us a while. Yeah. So I said special problems 4 and 5, but it was a really one problem only, right? Because it's 4 was find the shortest length, and 5 was find the shortest path. But we, smart as we are in our Dijkstra algorithm, have do both at the same time. So we're going to solve 4 and 5 at the same time. So if you're in doubt how to do this for the self-assessment, if you do, you can give yourself 2 stars for this thing, if you do it correctly, of course. Okay, so here we go. We have our vertices. We have to start from A, and I'm assuming all the alphabet up to T is there, so I'm just going to go alphabetic. A, B, C, D, E, F, G, H, I, J. Should have perhaps taken a different K, paper, L, M, N, O, P, Q, R, S. I'm getting there, people. C and T, and that's Z. All right. So here we're going to put our, this is going to give me trouble if I write here, but okay. Yeah, see. Okay, sorry, no, I don't know what this is. I've never had this. No, don't. Okay. So we have these 2 columns. In one will come the cost. So sorry, I cannot write in the top part. It might be weird, but so in this column will the cost, and here will be the path or the direction. I'll call it the previous vertex. How did you come in to this particular vertex? Okay, and we start. It's a lot of bookkeeping, so remember the first thing that we do is everything except for the starting point get value infinity. Okay, and then we take the first, pick the one vertex with lowest cost. There's only one, that is A, and so we pick that. Sorry. So that is going to be A, and then we also look at its neighbors, B, C, and D. And so we recalculate the costs. B is now 2 if you come from A, C is going to be 4 if you come from A, and D is going to be 1 if you come from A. All right, that takes care of these guys. A is now done, so I'm going to just make it red now. So I've done A. What's the lowest cost available? That is D. You remember, this is the part of the greedy algorithm, is that you always pick the one that currently costs the lowest to go to. Okay, so I'm picking D. So D is my no. Where is D? Okay, what are your? Now we mark the neighbors. A we have taken care of. F and G. So now remember, there's a cost to get to D. We have to add that to the new cost from D to F is 5, so that will become 6 if you come from D, and here it will be 5 if you come from D. All right. So that takes care of these guys. And yeah, so this and this one is now done. So I'm going to make it red. What's the next cost? Cheapest cost is B, or the remaining cheapest cost is B. So here is B. Where is my B here? And now I pick the neighbors of B. It is C and E. And I update the costs, C and E. Yeah, okay, sorry, C and E, if you want to follow. The cost to go to C currently is 4, but if I go from B to C, that would be the cost at B is 2, plus the new cost, which is 3. I hope you see that the numbers are sometimes hard to put on. Yeah, so this was 3, so that would be 5, which is not better. So I'm not going to do anything there. E, of course, has to be updated. The new cost now is the cost to go to B plus the cost from B to E is 1, so altogether 3. And this is coming from B. All right. So we have done with these guys. We put this. So we're done with B. Okay. What is the next cheapest one? Seems to be E. So I'm going to E. E, right? E. And what is his neighbors? C and H. Okay. C and H. H I can definitely upgrade, so let me do that first. The cost at E is 3, and then additional cost is another 3, so 6 if you come from E. And to go to C, the cost was 4, and the cost when you're at E and then go to C, that costs you 5, which is not better. So I'm not going to upgrade that. Okay. So this can go. Oh, no, that's not what I want to do. This one, this one. So, right. Sorry, I'm going to make my life a little bit easier. I'm going to add it to my favorites. Then I can go quicker with these things. So, what was it? What did I do now? E, right? Yes, E. See? Playing with my colors and my crayons, and then I get lost, right? Okay, next one is, the next cheapest one is C. So let me put that in my favorites here. Okay, so that is C. Where is C? Here. There's only one unexplored neighbor, that is F. Okay, sorry, I should have done this before I started, but okay. So F. All right, that cost, to go to F, it cost an extra 2, and in C it was 4, so the new cost would be 6, which is the same as the old cost. So I could update D, or I cannot. It doesn't matter. So you see here, sometimes there are going to be two choices. If I ever going to use F, there are two different ways I can use the road to F. So, but let's take it take the easy road and not update anything that is not necessary. Okay, so C is now also taken care of, right? Yeah. And the next one that we have to do is G. So we go to G. Where is G? Here is G. Oh, G is kind of a bit new guy. So what are your neighbors? G, F, and K. D is already dealt with. So F and K. I definitely can upgrade F, so let's do that. K, let's do that first. So the cost at G is 5. So I look at the orange, right? At the moment, the orange cost is 5, and then the cost from orange to green is 2. That is altogether 7. And this is if I come from the orange, which is G. And with the cost of F, if I am in G and I have to go to F, it's another additional 3. That's not going to make it better. So I don't need to update anything here. So this is done. So this took care of G, right? Okay, G. F or H, doesn't matter. So I'm going to pick F. Where is F? Here. You see, it takes quite a lot of time to get through everything, right? So we have to know the neighbors H, I, J. And remember, the complexity of the Dijkstra algorithm is n squared. We have here about 20 vertices, so that's going to be 400 steps, kind of, in the magnitude. It's luckily not as much, but still. So we have H, I, J, okay, and so what are the costs? Well, let's do the simple cost. I can be done, because the orange cost at F is 6 at the moment, and then we have to add another 2, so this costs 8 if you come from F. And J, if you come from F, what does it cost you? F4 to the cost from F, which is 10. 4 plus 6, okay? And then finally, can I get better in H? Currently, it's 6, and the cost at H is 6, and for going from F to H is another 3, so no, that's not going to make it better. So, okay, so that doesn't help. I mean, that doesn't do any more, so we can get rid of these guys now. And so this was F, right? Okay. Next one is H. Okay, H has some new neighbors that we have not inspected yet, O and L. the other neighbors are already done with. So where is O and here is L, okay. So this is easy, very quickly. Cost at H is 6, and to go to L, that is 1, right? Yes, that's 7 therefore. And to go to A, that's an 18, that's expensive, that's 14. And so this is coming from H. Okay, good. That's got this spell with these guys. So, oh no, here we are. So this is now done, and so that was H. The cheapest one is either K or L, so I'm just gonna pick the alphabetically first. K, where's K? Here's K. So what are your neighbors, K? Oh, J, N, and R. J, N, and R. Let's do the easy ones first. These N, if I come from K, that's so far the only way that I have come, add 4 to the current value, right? Add this 4, which is the cost from Kn, to the current value of that is 11. So that is now 11. And the cost for, if you come from K to go to, this is an R, sorry. My R's look like this. I apologize, but that's how my R look like. And so it's 7 plus 2, that's 9. Okay. And then finally, what about J? I have to, from K to J, that's 6, and K is currently at 7, so that's too expensive, so no, I'm not updating that. All right, so this means K is now is done. So the next one is L still. Yeah. L, where is my L? L is somewhere here. It has O as a neighbor. It has I as a neighbor. Notice that I is kind of, it looks weird that I have to go back, but yeah, that's how things are. Remember, orientation and directions are all only schematic, and they are not, on scale, they're not even necessarily correct, right? It doesn't mean that if these are cities with roads between, it doesn't mean that it's to east or the west. It's just a schematic representation of the situation, and sometimes we move, you see, there's a lot of information has to be printed in this little thing, so it's the designer that makes these dots a little bit farther apart and so on, so that it becomes legible. Okay, so let's mark these, because there are, now we're jumping over a bit all over the place. And M, so keep track. Oh, M is something we have not done yet, so I can first do that. So the current cost is 7, right? The current cost is 7, and to go from L to that's a 3, so that would be 10, and that is coming from L, the orange guy. Okay, what about I? I costs currently 8, and from L to go to I is another 3. That's not making it better. No. So I'm not going to do that. And then from O, I'm sorry about this, guys. From O to, that's currently 14. And if I go from L to O, L is 7, and the cost is only 6. So this will actually be better. Okay, so 14 becomes now 13, and this is if we come from L. Sorry guys, let me get this rid of here. Let me unplug this. Apologize, I thought I turned this off, but it didn't. Okay, so that takes care of everything, right? So I was not better, M I did, okay, yes. All right, so we see once in a, this is actually our first real update that we have, right? But yeah. So we can now dismiss all these guys. So, oh no, here it is. L, 8, 10, 10, 11, 13. So I have to pick I. That's the cheapest one at the moment. Where is I? Here. It has still two unexplored neighbors, namely J and M. Well, not fully explored. Fully explored. I shouldn't say unexplored, because they have actually been already reached, but as we can see here. And so, but we have to now check, do we get better values? In I, it's cost 8, and to go to M, it costs another 2. So that is 10, which is the current value. So again, I have the option to choose here, but I'm not going to do that. What about J? That's an extra, from I to J is a cost of 3, right? That's the weight of this edge. And the cost is currently 8 plus 3, that's 11. That is not an improvement. So this doesn't really add anything. So this was I, right? So let's take I out now. So I is done. 10, 10, 11, 13, 9. Oh, R is actually cheapest now. So I'm going to go to R, guys. That seems to me is the most promising to me. So R, where is R? Here is R, and what is its neighbors? N, Q, and T. Some N, Q, and T. There are two unvisited, previously not visited yet, so we can quickly do those. Q, the cost at R is 9, and then from R to Q is 8. So this will altogether be 17. And this is coming from R. And T, so coming from R, that is the current cost 9 plus 5, that's 14. Okay. And then finally N is 11. If you come from R, which costs already 9, and then go to N, it's actually cheaper. So this becomes 10, so this becomes R. So even this one is cheaper. So you see, backwards doesn't necessarily mean forget it, right? That's why we mark them and we check them. You might have perhaps at some point thought that that's something you can do, but it isn't. So all right. So now we have several 10s. That's the cheapest one. So let's do them again alphabetically. Do J. You see, it doesn't matter which one you do because you have to do them all anyway. J. J has cost 10, and what are its neighbors? M and N, right? Yes. To go to M, that would be 10 plus 6 is 16, but that's not improvement. And to go from J to N would also be 10 plus 3, 13, so that's not an improvement. So I'm not going to do anything with that. Okay, so we can all get rid of this and dismiss J also. Then what about M? Okay, so now M is in consideration. M has still a couple of neighbors that might, N is a neighbor, O and P are neighbors. The other neighbors are already done with, right? So, okay, let's mark them. O, P, oh, that's the first time we get to P and N. Okay, so let's do P first, right? Because we don't have to think, it's gonna be better. So coming from M, it's a cost of 10 at M, and you add another, so this is perhaps a little bit, you might ask, what is this 2 or 1? This 1 must be for this one, because otherwise there's no value for this one, so this must be 2. Okay, the picture is not the greatest. I'll make sure on a quiz that it is less ambiguous. So 2 plus M, that's 12, so that's the cost to go to P. Did I mark it? No, I didn't mark it yet, so 12. And that's coming from M. Oh, I marked that already. Okay. And then what about N? Currently costs 10, and from M to N is 5, so that would be 10 plus 5 is 15. That's not going to be better. So N is not, so N is no longer interested. We're not interested in N. Oh. What about O? Currently costs 13 to go to O. If you're an M, it costs 10, and then from M to O costs you another 4. That is not going to be an improvement. So no, that's it. So M has served its purposes. So we can now take M out. There's 10, 13, 12, 13. N is still the cheapest. So I look next to N. Where is N? Here. There's only one neighbor that I need to inspect. That is Q. Currently 17. That's kind of expensive. And from N to Q is only 2. That's much cheaper. So from N to Q, N is 10, right? And then there's another 2, so altogether it's 12. So forget it. I'm going to come from N. Sorry, N, not Q. It's always where you come from, right? Okay, I'm coming from N. And that's it. Nothing else to do here anymore. So this can go, this can go, this can go. So this takes care of N. Let's see. 13, 12, 12, and 14. So I'm going to do 12, right? Let's pick P. P, it has neighbors O, S, T, and Q. Quite a lot of neighbors. So O, S, Q and T. Okay, let's see what we get. Well, first of all, I know one, S. So this is coming from P. I have so much, it's so small now becoming that some things are, P is this still, that's not really read yet, right? So this is S, and that, what's the value? So P has value 12, and from P to S is another 2, so that would be 14. So if you're coming, the road that comes from P, that is value 14 for S. Okay, that takes care of S, because it's getting a little bit, do one at a time. Then let's look at O. In O, the cost is 13, the cost at P is 12, and going from P to O is another 2, so 12 plus 2 is 14. That doesn't improve, so I'm not going to consider it. What about Q? The current cost at Q is 12, and that's obviously not going to help me because a P is also 12, and it still is, it's not much, but it's still 1, so Q is also not going to get an improvement. I did already S. What about T? That is, is 1, the cost is 1, and the cost at P is 12, plus 1 is 13, which is an improvement. So this is going to be 13 if I come from P. Okay, so, and that then takes care of these guys, okay? This is getting, oh, sorry, I'm going to have to make my pen a little bit less thick. Oh, but this is my, okay. I'm sorry. The next one is 13, 12, and 13, Q. Sorry, it's getting a little bit, Q, and Q, it doesn't have too many neighbors anymore. It's going to be much quicker now, but there are not that many points left. So 2. Q costs 12, and then from Q to T is 3, so that will be 15, which is not an improvement. So forget about that. So all this was not. So I can also rule out Q. Q is now also gone. Then we have O to consider. O has only S I have to inspect, whether I can get cheaper to S now with via O. It costs 6 from O to S, and O itself is 13, so altogether 19, which is not an improvement. So again, this doesn't help me anything, so I can make this. Okay. So we have now what's left. S and T are left, right? So sorry, it seems like S is done out, but it isn't. So 13 is the cheapest. I have to choose 13. T, sorry, yeah, T is the cheapest. T, it has only one neighbor to consider. That's the guy that I want to go to, Z. And so that's the first time that we know how can we get to Z, or how much it's going to cost at least. It's 8. So 13 plus 8 is 21, and that is coming from T. Okay? Now, let's see whether S is giving me better odds. Well, odds or better cost, actually. It's not odds, right? It's not random. It's, sorry, no. What did I do? T here. No, T. So T is done. T is done. T is done. So only S is left to be done. Sorry, it's not visible, but it is really S still. And it has only one neighbor, Z. And so the question is now, does it become better? S costs only 14, and from S to Z, it's only 2. So it actually means it would be 16 if you come from S. And all the vertices have been dealt with except for the last one, the end vertex, right? So just, and so we now know that is, so number 4, question number 4, the answer is 16, and question number 5, what's the answer? And that's, we have to now work backwards from Z. If you're in Z, right, if you're in Z, I'll mark it, if you're in Z, then you have to come from S. So look up S. Let's do this in a different color. That oh no, that's not, sorry. Okay, so we start with Z, and I'm going to do this in a different color so that you follow, because I'm not sure what everybody is following this part. I have to do a color that is kind of blue, perhaps, light blue, let's see. So from Z, you come from S, so you put S here. Then you go, oh, this is going to take me forever. Okay, I guess I have to also put this one as one of my favorites. So then you look at S, where you come from P, okay, P. P, where you come from M. M, where you come from L. L, you have to come from H. H, you have to come from E. E, you have to come from B. B, you have to come from A, and that's of course where we want to come from. And that's the path. So you see how I backtrack myself through this algorithm, and that's why the second column was important as well, because it gives us the path back. If you forget somehow to do something, you might all of a sudden get stuck because you didn't find the previous case. So, okay, all right, that's the homework. It's also, again, review for, I will ask you one like this again on the quiz. So I'll do perhaps one extra in the review session for the quiz. Then you have done quite a lot of these. That should be enough to get you through it.